Dorosh, cybersecurity implementation lead at LABYRINTH, one of our sponsors, and it's a talk from a bit of different perspective for us today. It's about detecting open source honeypots. So, should be fun. The floor is yours.
I hope you can see it. First of all, hello everyone. So today we talked a lot about the site when we deploy decoys, like how do we do it, how we can do it effectively. But I want to get to another side, like from the adversary's perspective, what I can do to avoid what you did. So let's continue. You already know this about me, so I will skip that. And we first start with talking about what is a honeypot. I'm joking, we won't. So I will just state why do we even need to think about it. It sounds intuitive, like deception is about giving false information, giving, decepting basically the adversaries. But I would like to make it into concrete bullet points, so to make this more clear. First of all, it's open source's like advantages and disadvantages. Open source is really powerful tools. It's really great for different types of companies, for researchers and etc. But quite often it comes with an issue that we need to involve sometimes. This is, by the way, exactly what I was asking some of the people who were presenting earlier. And we need to understand that not everybody has those resources to make it work as it's supposed to. So this is one of the things. Next, increase credibility, gather more data. I believe you know about different approaches to cyber deception, because cyber deception can be used, for example, for just detection. So what does it mean? Decoy detected something, you say, okay, and automatically stop it. Like, for example, with API request to, I don't know, EDR or something like that, to isolate the host. But there's also an approach to cybersecurity when we allow the adversary to play as long as they want, and we gather intel. So, of course, it's depending on you, on your goals, but still, we need to increase credibility. Next is about knowing where to look during penetration testing. So this is about pen testers, people who work in offensive for good reasons. And, it's really important for them to avoid such kind of decoys to get more results about real hosts. Sometimes during penetration testing activities, people shut down deception, but I really like when they don't, because it really shows the true power of cyber deception. You see how the adversaries will do such activities, which tools they will use, and whether they will fall for those traps. And, of course, pen testers are good guys, but it doesn't mean that the same techniques, the same actions will be used only to help you. It's also about knowing where the adversaries can look. And adversaries, it's not about only real people, but also about malware. In the previous talk, my colleague mentioned Mirai. So on the screen you can see it's ZH-Trap. It's also malware, and its goal was to create a botnet. What it does, what is special about it, it was reported in March of 2021. What is reported about that is it first turned its victims into honeypots, to gather more IPs for further targets. So anybody who contacted with this host, the IPs were recorded, and then malware used it to probe and continue. But also what it did, it scanned the devices to identify whether they are decoys or not. You can see some of the examples of what it used. And this is also one important thing. So we need to understand how decoys can be detected to avoid such, for example, automated activities. Okay, let's continue. So how do we detect them? Extremely simple. We are looking for inconsistencies. This is our basic rule. at some point, I like to call it vibe testing, because basically it's about finding, when you find some inconsistencies, you get suspicious, you dig more, and turns out that this is a decoy. So what it can be something in file system, it can be some protocol quirks, it can be, if you're talking about open source, one of the great advantage for us as the adversaries is that we can look inside the code, so some hints from there. So yeah, this is what we will be doing. Let's see. Some notes before we begin. First of all, decoys are investigated separately from environment. So I tested only decoys without them interacting with the rest of the infrastructure, because it's also important and it can tell you a lot about this host. Like in the next couple of days, there will be plenty of trainings, and one of them will be about P0F, as I saw in the agenda. So I really recommend testing it. It's really important too. Like, for example, if the adversary, if nothing happens to the host, like at all, no traffic goes in, no traffic goes out, it's really suspicious, because why do you need this host this way? Why do you need it in the network? Next, we are okay with triggering them. So we are okay with triggering alerts. It's fine for us. We are just playing around. Also probabilities. So everything that I will show, you cannot take just one case and, depending on the results, say that it is a decoy. It's about complex. This is why I talked about vibe testing, because you gather everything and it gives you this probability. This is a decoy, because you see, I believe you're all professionals, you're all engineers, and you know that sometimes tools can be such badly misconfigured that you can think that this is a decoy, but it is a real host. So we are talking about that. And as I mentioned, look at broader picture, so you need to analyze all information that you have. What are we dealing with today? We have pretty popular test rabbits, I call them. I tried to do something, mainstream, so in my opinion, just easier. And we will be using extremely basic tools, so nothing really special, but it will be enough. So let's begin. Our first decoy, Cowrie, is like a celebrity today. It was mentioned almost in every speech, and I will also mention it. We already know that this stuff is supposed to emulate SSH, telnet, okay? We can deal with that. And we have a host, I found it. So to make this a little bit more interesting, I haven't configured any of those. I haven't deployed them. It's just something that I found or asked my friends to set up for me, so that I don't know what exactly I'm dealing with. So this is what we have, pretty basic. Okay, SSH, telnet, HTTP, okay, that's fine. Our first case, it's a normal reaction to abnormal events. This was what my therapist liked to say about, different situations, especially like war happening, and etc. So the idea here is that, decoy can really great emulate activity if it's normal, like normal operations, like checking files and etc. But what will it do if something goes wrong? It's about edge cases that when we are creating decoys, we need to understand and remember about. This is what we see. You can see here okay, I didn't put red square, so you just need to check it. I put wrong protocol version. SSH protocol version, and you can see the difference in responses. Protocol major versions differ for the first one, for decoy, and what we see invalid SSH identification for real host. And this is backed up by the code. You can see where it's deployed. Our next test while we are here, so I tried my best to avoid exploitation, to avoid getting on hosts and etc. But while we are here, why not? So I tried some dummy credentials. Unfortunately, they worked, and this is a really big flaw when you put wildcard right in here, because You will be able to connect to the host, but if you check, for example, ATC passvd, ATC shadow, you won't see this user. Of course, it can be on real hosts as well, especially when we are doing some bad things with spam modules. But still, this is also a sign of decoy. Next, it's about getting hints from developers. Developers are great people, and I really enjoy when they add comments because I'm not a software engineer, and sometimes it's harder for me to understand what they have written. And you can see that they have specifically left a note that users feel should be avoided. So this is like when you see red numbers on black screen, you think of Matrix, you think of Metal Gear and hear Invisible by Duran Duran. This is the same type of story. It's something so basic, so classic that also can bring suspicion to your decoy. And this is what we had on this host. Next, while we are also here, there are tons of ways that we can interact with. I decided to add only one, which is user add and add user, which was a little an interesting thing when I first saw my Linux machine when I was a kid. I really didn't get the idea why they are different and why the words are swapped. So I decided to add here as well. You can see that user add command provides you output as the script add user, which is also not okay, and it's also specified in the code. You can fix that. And cherry on top, 1, 2, 3, who can find it? Here it is. Also should be avoided. This is my honest reaction when I saw it when dealing with web. Let's see what we have next. Next, we are dealing with Conpot. What do we know about Conpot is that this is ICS honeypot. Okay, dealing with some OT, we like it. Our next test rabbit, and you can also see what I told you about getting as much info as you can, because this screen itself provides us a lot of data. First of all, you can see that there is a lot of different protocols, and this a decoy, you can see it's 20 seconds, okay, there are SSH, Telnet, web, etc., all in there, which also can raise suspicion. So it's also important to limit number of ports. It also can raise suspicion. And it is ICS, and for some reason, it's stored on GCP, which is also sus, now we will be dealing with that. Okay, my first test will be about Modbus, and my first basic instinct was to send a function code to read device identification. I wanted to know what is that. You can see that I'm weird, and I decided to just form my packet. So this is what I did. You can see this function code in here, and you can see that results on the screen is Siemens Sematic 7200. To say it's really old stuff, it is extremely old stuff, and you can see that it was discontinued in 2017. It's like a lot of time ago, but still we see it. It doesn't mean that this is a decoy, but it gives us a hint that it can be. And you can see that it was also written in the config. I also want to show you some of the interesting things, like how this process actually works. I also was running some scripts, to automate this stuff. And when I did it, I found an error. You can see it on the screen. It's about the string was too long. After seeing that, I decided that it would be great to see why so. I captured some traffic, and you can compare. So this one that appeared is from decoy, and the second one is from real host. If we strip this packet, strip what we have in data, the only data that we see in decoy is that the device is on, in some information about what exactly this slave is. It's not enough. We need to provide more. And this is the code of the Nmap script. Okay, let's continue. ICS, we also have SNMP. SNMP also is really easy to test. I use default public string. And we also see some issues. First of all, it's that the name, pump control unit, usually in real critical infrastructure, this data is more precise. The same happens with DOE, Department of Energy, I believe. Also, we see uptime, seven-ish minutes. Okay, interesting. And all of the data that is supposed to transfer, it's empty. We don't get anything out of it. It's also sign of a decoy right here. And last but not least, we saw that there was open 80 port, or I can't remember exactly what was on that slide, but there was web. And you can see that this web, it's pretty basic. So those are two separate decoys that we had, that I found, but still they're running under the same HTML page that we can see in the source code. Some extra info, I was playing around with this a little bit more. You can see last modified, it's 1993, so it's older than me. And it's also sign of a decoy. It's also one of the most prominent ways to say it. This is a Conpot. This also provided in the default configs. Let's continue. Dionaea, you can see it on the screen, and I hope I spelled it correctly. Tricky word to say. But we won't be talking about plant, we'll be talking about decoy. And you can see that there are a lot of protocols, and we are really, we can be trapped in a situation, I call it like all-in-one, like shampoo, conditioner, body wash, etc., when you have products that does everything, but it does it poorly, so it doesn't do good any of that. So let's see what we got. Test rabbit. Oh yeah, that's a lot to unpack. We won't be doing all. First of all, MySQL, okay. This is also one of the examples how I even started my investigation. You can see that it is a really different thing to show just a number of A's. So I decided to continue. I once again gathered a network dump. You can see that this is salt. And you can see it in comparison to real MySQL. So always be cautious about salt. Next, we have FTP. And this example shows us how protocol quirks can also signalize that we are dealing with decoy. You can see that I simply tried to connect. So I wasn't doing something special in here. I was doing just normal operations. And you see what happened. So I typed in name, then it allowed me access to shell, and it never asked me for a password. And this is an example of how it works in the real FTP server. And you can see, by the way, also a welcome message, but I wouldn't say that it's much of a signal because it can be customized, and this stuff sounds pretty basic, pretty default, but also can be used if we are getting multiple things in once to evaluation. And last but not least, example that we will have, Glastopf. This stuff is supposed to be web application honeypot. So yeah, I'm lighting some web. But it's also really funny stuff in terms of how it does it. I will just show you. It will be a quick test. This is our test rabbit. Looks pretty simple. And you can see anything that you put after the IP address, it will generate you a page. I have put the whole Romeo and Juliet in here, and you can see that I still got a page. Do you think that this is normal for the real application? I don't think that you have such path in there, but it's possible with Glastopf. So it's okay. So we did a little play around, detected some honeypots, but you know it's really bad for scaling if you do everything manually. We want to avoid it, and there are some automation tools. Some open source. No, I will talk only about open source, so no worries. Let's see. First one, you can use Nuclei. I really like this tool because of its how you can customize it. You see its format really cool like that. And this is template that you can find, honeypot detection. Really easy to use. We will see which examples, which decoys it covers. So what it does is basically absolutely the same that we did. It finds some signs that signalize about this or that decoy and just run it in automated manner. I even tried it on a couple of decoys. You see it was, whoa, I can't see it. Okay, so it was Dionaea. You see, and also some web, and you see it was Conpot. So you can see that it was successfully detected. And the full list of templates that you can use is there on the screen. Of course, it can be and it should be expanded. I did it for my personal purposes. I haven't posted them because I need to prettify them. You know, when I try something, it looks really bad. I need to clean it up. Next. It's Honeyscore by Shodan. It also provides it. By the way, this is something that you see when you go to Shodan, find some host, and you have this flag called Honeypot. I like this a little bit more because, first of all, I don't need to configure anything, but it's also a downgrade because I cannot check something in the internal network. And what I like the most is that it doesn't tell you for 100%, it assigns you a score from 0 to 1. So how likely this is a honeypot. It was created for raising the awareness about this problem that researchers, companies just putting anything, you know, just default configs on web and expect to find something except for crawlers. So, okay. Good luck with that. So yeah, can be used. And also, I found Checkpot. It was written that it was by Honeypot project. And the idea is that it allows you also to write your assisted checks. I like how it's called karma points. So karma points is about how likely it is to be a decoy, a honeypot. The downside for me is that you still need to write them. You still need to involve some time to understand it. But it can pay you back, especially if you are on a offensive side, if you are a penetration tester, or etc. I always recommend to get more information, more resources about what can be done, because, you know, I'm not the only person who does it, and there are plenty of cool people who did plenty of researches, so feel free to check it. And to summarize, I want to raise a question, because you see, who's responsible for that, for those poorly configured decoys? At one side, we can say that it is responsibility of people who use them to configure it. But we already discussed that it requires time, it requires resources, not everybody can do it. And we can also think about that developers who made it could have added more, you know, more templates, more different things to do, you know, for differentiation, so it won't look the same. Okay, but I would say that it's not anybody's fault. It's just something that we should be acquainted of, because even if devs added more configs, still they will be publicly available. So what I would think about to make it extremely easy is what we discussed today is about LLMs. Maybe we can try and use them to create those configs. But this is just an idea. So it's up to you to decide whether you want to try it or not. I haven't tried it. So that's all from me. Thank you very much.
Thank you. Thank you. Questions? We have some 5 minutes. Yep.
Thank you for the presentation. So you did mention about some scripts for, at least from the presentation, I know you ran some tests on Cowrie, Conpot, Dionaea, and Glastopf.
You mean my personal tests or automated ones?
I don't know, but have you run anything yourself, or did you use the tools like Nuclei or?
So my speech was divided in two parts. One I did fully manually. I wanted to show, the simplicity of how it can be done, because of course I can show you output, but you won't get the understanding how it's done. It's just my approach. And yeah, for automatization, I tried some decoys, and you can see the result for some. Unfortunately, this one was not really good, but maybe it was my fault because I didn't invest enough time into writing those stuff. So you see, it was a decoy, but karma points is still 80.
Right. Did you have any plans of automating whatever you did and do a scan all over the internet to see how many you can see or expose?
Yep. I was thinking about it. Maybe I will, publish those templates that I did for Nuclei. It works kind of similar like this stuff. And yeah, maybe it will help somebody to detect some stuff.
Good. Last question, if there is not much. Oh.
Okay, I'll return back to this.
Thanks a lot for the presentation. Can you please talk a bit about the methodology you used while you were doing these manual tricks? Did you study the source code of the honeypots to try and find out those tricks, those detection mechanisms, or did it by trial and error?
It's really nice question, so thank you. I would really like to say that I have a methodology, but unfortunately I'm extremely lazy. And also, so I did closely to what I said about vibe testing. Of course, so my first, I have some kind of this lazy methodology that I did myself that works only for me, is that first I try to do the easiest things, see if it works. If it doesn't work, I go to source code and go further with that. So yeah, I don't say that I recommend this approach, but it's something that helps me make this process a little bit more interesting. I think of it as a gaming, find something. So yeah, this is what was used in here. Basically, I would say that my methodology was based on, basic penetration testing operations. But yeah, it was modified to make it more interesting for me to do. Thank you.
Thank you, Anastasiia. Again, please join me in another round of applause.